I am Dr. W. Gurnage from Kamla Nehru Mahavidyalaya, Nagpur. Today we are discussing the synthesis and reactivity of neutral boranes. And as we know, neutral higher boranes can be synthesized by the pyrolysis method. And by using this method, the tetraborane, neutral boranes like tetraborane, pentaborane, decaborane can be synthesized by using pyrolysis method under controlled conditions. And there are two types of borane. One is a their formula is first two types of boranes. First borane have the general formula BHN BH3X, and in this case BHN BH3X. N is the number from 0 to 10 and X is the from 1 to 3. And there is also another general formula of borane, and that is the BHQ and BHP and HQ. So by in this case Q is the additional hydrogen present other than the boron. So by using this formula, there are mainly three types of boranes. One is a Nido, second is a Arachnoborane, and third is a Clozoborane. So detail about all these boranes and synthesis of these neutral boranes we are discussing in today's part. So again today's topic is the cluster 1 boron hydride, and this is the part number 4, and in this part we are discussing synthesis and reactivity of neutral boranes, neutral higher boranes, and another method is also there, synthesis of tetraborane by using the hot cold reaction method. So there are different routes of the synthesis of the neutral boranes, and two different route we are also discussing, and also hot cold reaction method we are discussing for the synthesis of higher boranes. So in this case, the synthesis and the reactivity neutral higher boranes like tetraborane, pentaborane, decaborane can be synthesized by using the pyrolysis method, and from the lower boranes like diborane under control conditions. So this approach is feasible, and there are two types of general formula of the borane, and here first one is a BHN BH3X. So N is nothing but the N varies from 0 to 10 and X is from 1 to 3. So this is first general formula of neutral boranes, and there is also another general formula of borane, and which is a BHP EHQ, where Q is the number of extra hydrogen as compared to the boron. So there are two types of general formula of the borane, and formula is given here. So here we are discussing the synthesis and what are the different routes to synthesize the neutral borane, and generally there are two types of borane having the general formula BHN BH3X, and second is BHP and HQ. So in this case, by using these two general formula of the boranes, neutral borane can be three types, and these are mainly Nido borane, Arachnoboranes. So here three are shown. What is Nido? Nido boranes means nest-like structure they have. Nido means nest, and so it has Nido borane have open skeletal structure. And second, Arachnoborane, and the structure is like a spider or web. So arachno is a spider or web like, and more open skeletal structure is there of the arachnoborane. And clozo means closed skeletal structure. So open skeletal structure, more open skeletal structure, and closed skeletal. So there are three types of the borane, and first is nidoborane, arachnoborane, and the third one is a clozoboranes. So here in the next slide, how they are related, Nido and Arachno, detail about that is shown in this table. So in case of synthesis and reactivity of neutral borane, so Nido borane is shown here, and second is the Arachnoborane. So in the first case it is shown number of BH unit 0, 1, 2, 3 up to 8 number of BH unit. So in case of Nido borane, BH units is 0, 1, 2, 3, 4, 5, 6, 7, 8. BH units are given, and here this is N, and here BH3 unit are the fixed, X is 2 fixed, what is the 2, 2, 2, 2, so it is fixed. BST unit are fixed, number of BST. So X is nothing but the number of BST unit and it is fixed too. This A is changing, this is N is changing. N is the BH. So 0, 1, 2, 3 that. So it is number of BH. And here different, when it is BH is 1, 0, so what is, it is 0 and start from 2, then what is B2H6 is the formula of the borane. In case of these are the Nido borane, and BH1, BST2, we get B3H7 and B, this is 1 and these are the 2, so B3 and H7, 6 and 1, 7, B3H7, and again here the star is there. Star indicate the borane is a unstable borane. The two boranes are there, Triborane and Tetraborane, where there is a star. So these two boranes are unstable. And third number is this is 3 and 2. So B5H9, in this case B6H10, B7H11, B8H12, B9H13, B10H14. So here these are the 6 and this is 8. Here borons are here. Borons are 8 and here are the borons 2, 8 and 2 10 and 14 hydrogens are there. So in this way we can calculate these are the Nido boranes. In case of the arachnoborane, Q is 6 and X is 2 fixed. Here X is 3. Here 3 is there, here should be 3 and Q equal to here again it is changes. What is now 0, 1, 2, 3. So in case of arachno, BH 0, BST 3, this is fixed, and here we obtain then B3H9 because it is 0, BH is 0, another BH1, BST, so we get B4H10, so 1B and 3B, B4H10, and in this case we get B5H11, B6H12, B7H13, B8H14, B9H15, B10H16, B11H17. So these are the formulas of the different types of boranes, neutral boranes, and higher boranes are also shown. So Nido and arachno are given depending upon the number of BH unit, depending upon the number of BH3, and depending upon the value. So here this table shows the different types of neutral boranes. Now in case of synthesis, different routes are there of the synthesis, and there are 3 ways, first, second and third. In case of first is a gain and loss of BH3, and this in this case this method is synthesis route is used to convert a borane of given N and X borane of some N but different X. For example is here. So in this case BH is N, BH3X. So in this case BHN is fixed. Now BH3 X plus 1, because here we have to add BH3. So in case of this addition in the first route, here we have to add BH3, and so here this is the from this is converted to this one, but here we have to add plus BH3, and if you add one BH3, then BH is same BH3 X plus 1, because we are adding in the first case BH3. So gain and loss. So here if you are adding, then plus 1 is here. If there is a loss of BH3, but then again we get same compound. So first is the gain and loss of BH3. So addition of BH3 we get this one, and removal of this BH3 we get this one. So first is a gain and loss of BH3 unit. Second route of synthesis is this second route of synthesis of neutral borane is used to convert a borane of given N and X to one of the next value, that is lower N and X. This method can be explained and given here. So in this case BHN BH3X. Now here we have to add the hydrogen. What is here? Hydrogen is here, gain and loss of H2. So here in this case plus H2 we get this one. So here H2 means plus 1 here and minus 1 here. So plus hydrogen H2, and if you remove minus H2 we get this one same again. So addition of this hydrogen, because there is a gain and loss of H2, so plus H2 we get this one, and back minus removal of H2 minus H2 we get the initial product. So in this case, or another way is given here, BHP HQ, then we get BHP and HQ plus 2 because we are adding hydrogen, so plus 2, plus 1 was there, now plus 2, so 2 molecules are there of hydrogen. So in this way, this is the second route of synthesis of the neutral borane. Third one is a gain or loss of BH. Gain and loss of BH. In this route is used to convert given N and X borane of higher N but same X. This can be understood by following the reaction. So N can be changed but the X remains same. So here we have to add the unit BH. What is BH? Gain and loss of BH. So this is the compound plus H2 plus BH. If you add BH, so here plus 1. This is as it is. And removal of BH, we get again this one. So three route of the synthesis of neutral boranes are there. One is a gain or loss of BH3. Second is a gain or loss of H2. Third is a gain or loss of BH. So different routes are there of the synthesis of higher neutral boranes. So here by considering these three types of reaction route for higher boranes obtained as also shown in the next slide. So by considering these three types of reaction route, some examples of higher boranes are how they are obtained are shown in this slide. So here B2H6 diborane, which can also be written BH0 BH32, and first way plus BH3 we get this B3H9, and if you remove again we get back. Now from this plus BH we get B4H10, see here BH, B4H10, and removal of this we get again back this compound. From this compound again now we have to add BH3, what is then B here, we get B5, here is a forward here in this way, so we get the add this BH3 and also removal of BH3. In this case now from this to this BH plus BH minus BH. So this is A, this is B, and this is C. And in this case in the B, what is B3H7 plus H2, we get this compound. Removal of H2, we get this compound. So in this way, different route of synthesis of the higher boranes are shown in this diagram. So higher boranes, higher neutral boranes can be synthesized by taking this an example of synthesis of higher boranes. And in the next slide that is shown, in this case the pyrolysis of the gaseous diborane is carried out in a sealed vessel at 100 degrees Celsius, and the reaction is complicated, and recently it is observed that by the scientist Greenwood and the Gretox is the name of scientists. They have given this method of pyrolysis of gaseous diborane in a sealed vessel at temperature 100 degrees Celsius. The reaction is so complicated, but this method is fully given by the Greenwood and the Gretox. So according to this scientist, formation of higher boranes take place through the formation of fragmentation of diborane BH3, which then react with the further and give the diborane to form different types of product which are shown in this slide. BH3, B3H7 and hydrogen. So different possible routes or different possible reactions which are giving the different products are shown here. So here is a diborane forming two molecules of BH3 unit. So this is the synthesis of the higher neutral boranes by using the pyrolysis of gaseous diborane. So higher boranes can be synthesized by using the diborane, and this pyrolysis of the gaseous diborane is given by Greenwood, is the name of scientist. So in this case, this is the diborane and forming two molecules of BH3, and this BH3 further react combined with the B2S6 and we get B3S7 and hydrogen is replaced. So this intermediate BS3, B2S6, B3S7 react further to form higher boranes, which are shown here. And so what is BS3, B2S6, B3S7 further react with and forming the higher boranes. So BS3 unit and B3S7, this is highly reactive and forming B4EH10. This is the higher borane, Tetraborane 10. Another B2S6 react with B3S7, star indicate reactive and forming BS3 and B4H10. This is the compound higher boranes is obtained. Another B4H10 combined with BS3 and forming B5H11 higher boranes. So higher boranes can be synthesized by using gaseous diborane by using the method pyrolysis. So these are some reactions of synthesis of higher boranes by using gaseous diborane. Now there are series of different types of reactions which are taking place and which give the higher boranes. For example, higher boranes like here B3H10, B5H9, B5H11, B6H10, B6H12, B10H14. This type of higher boranes can be synthesized by the pyrolysis method, and out of all these most stable product is the B10H14. B10H14 is also known as the decaborane 14. So this is the stable product in this higher borane. Now there is also another route of synthesis of tetraborane by using the hot cold reaction method. So for this case it is shown, this is the outlines of the arrangement for the synthesis of hot cold reactor. Here is a crushed ice. This is the crushed ice, and liquid nitrogen we have to keep it here for minus 78 degrees Celsius, and this cylinder is kept in a crushed ice. So at the bottom there is a crushed ice, and in this container, in this cylinder, we have to take the B2S6 means diborane. Diborane is passing through this outlet and coming inside here. So here is a diborane, and this is the tube coil we have to, this is the coil we have to put in this solution of diborane. And so this is the here, and after that here is a bath of glycol is there, and we have heat in this heating, and this is the heating jacket, heating coil also we can say, and this is the glycol, bath of glycol. Here this is the outlet to collect the product before H10. So here is a, this one is the outer wall and this one is the inner wall of the cylinder. So after making all this arrangement, again now the diameter is given here 8.5 meter here, 8 centimeter, and this is the length of this is 25 centimeter. So after arranging all this thing, after passing diborane, it coming here, here is a bath of glycol, here is a ice and liquid nitrogen. So tetraborane 10 can be prepared by using this method, and this is the most effective method for the large scale manufacture of the tetraborane 10 by using the pyrolysis of the diborane, and this method is generally carried out in the hot cold reaction as shown in this figure. So because this is the hot and this is the cold, therefore the reaction, this method is known as hot cold reaction, and this is the reactor shown here. So in this case, this figure shows the hot cold reactor for pyrolysis of the diborane. The diborane B2S6 first introduced in the evacuated reaction mixture, then it is frozen by keeping this cylinder in a liquid nitrogen, and after that liquid nitrogen is then replaced by crushed dry ice. First we have to place this cylinder in a liquid nitrogen. After some time it is replaced by the crushed dry ice in a acetone or chloroethylene, and in this case a reaction mixture is shown here. Reaction mixture, liquid nitrogen is then replaced by the crushed dry ice and some acetone and or sometimes trichloroethylene, and inner reactor contain diborane. kept in an ethylene glycol, and this ethylene glycol we have to heat at 120 degrees Celsius by using electric heating coil is there, and the diborane undergoes pyrolysis to give the B4H10. So in this method, this is the diborane come inside. Here is the first liquid nitrogen, then it is replaced by crushed ice, and this is the heating coil is here, and we have to heat, and pyrolysis of this diborane take place, and we get the product B4H10 from this outlet. So by using this method, by using the electric heating coil, we have to heat the coil, and after that diborane undergo pyrolysis and give the B4H10, that is Tetraborane 10. So by using this method, Tetraborane 10 can be obtained with 80% yield. So 80% is good yield, and the complete procedure required 2 to 3 hours. So here is the reaction is shown. So this is the diborane, 2 molecules, and forming B4H10, and hydrogen get evolved. So by taking the 2 molecules of diborane, we get the B4H10, and hydrogen is replaced, evolved, and B4H10 is the final product. So this Tetraborane 4 is obtained by hot cold reaction and in a hot cold reactor, and this is the best method for the synthesis of Tetraborane 10, and using hot cold. In this reaction also there is a pyrolysis of diborane is taking place. So because the ice is cold, and also we are using at the bottom of the cylinder, and in that reactor we have taken the diborane, and we have to keep it above the ice bath, and then pyrolysis we have to heating coil is there, we have to maintain the temperature 120 degrees Celsius, and then pyrolysis is taking place, and we get diborane is converted into Tetraborane 10. So this is the reaction which is taking place in the reactor. So in today's part we have seen the different types of product of synthesis of the higher boranes. So in today's part we have discussed what is the synthesis and reactivity of higher boranes or neutral boranes, and we have seen there are 2 formula of the boranes and different route of the synthesis by addition of BST, removal of BSC, gain and loss of BST, gain and loss of H2, gain and loss of BH, and different product we get, that is the higher boranes. And another method is a hard cold method also we have discussed of the synthesis of tetraborane from the diborane. So this is an important part, and detail about this borane, and mainly there are 3 types of borane as we have seen, Nido, Arachno, and the closed boranes or closure. So all this part we have discussed in today's presentation.